Hey guys, this is Crystal with Open to Public HVAC School. Today we're going to talk about pressure switches and how to test them, as well as what else it could be if you have replaced your pressure switch and you're still getting the same error. Let's go. We are here at our inducer motor and our pressure switch. Now your pressure switch can look a lot different, and I will show you guys what those could look like. This is one, now not always, they do have some newer units that look like this, but for the most part I've seen a lot of older unit pressure switches that have this big metal style. Make sure first and foremost, before we even test anything in here, this is your hose here, and that's going to go back into the inducer motor section. So again, this is a much different design. It is a carrier design. For the most part, you're going to be able to see that connection where the hose hooks up to. So make sure that your connection is good back here on one end of your hose, and that this connection is also snug. If you're noticing you're able to remove the tube easily, what you can do is either purchase a new tube, and it doesn't have to look exactly like the original, as long as it's designed for an inducer motor. You can either do that, or if you have enough tube, what you can do is cut it back a little bit and reattach it so that it becomes snug against this nipple here, just to ensure that it's not a loose connection, or maybe your hose is starting to go bad and just getting old. So double check that. And then with most electrical loves a really snug connection here. So make sure that your two line through connections here are snug, they're pushed in, and that there's not any cattywampusness, new word invented there. And then from there we can start process of elimination. So a common mistake I see even technicians do is they jump around the pressure switch and all of a sudden everything works and they think that's it. So they replace the pressure switch, and then they're having that same error code, which a lot of them are, say, 3 flashes. I think one is 31 I've seen that'll say pressure switch stuck open. Now what that means is it doesn't mean the pressure switch is bad. The pressure switch could actually be doing its job. So just to give you an idea, as we were talking about, a pressure switch can look different, and this probably looks familiar to many of you because a lot of the modern day pressure switches look like this, or some of you have Honeywell, which are kind of larger, more big boys. But the important thing to do when you are purchasing one of these, if you do discover it's bad, is to make sure that the negative pressure lines up. This is a -0.6 pressure fall. Make sure that that matches, and make sure that if it does say PR, you get a pressure switch that says PR, or pressure rise, not pressure fall. If you're wanting to replace your tube like we were talking about a minute ago at the furnace, you can buy these sort of things, and you have to make sure that it is rated for the correct pressures. And obviously it needs to be a material that can withstand a little bit of heat. So you can probably find a little smaller than what we've got in store here, but we do carry these, and it is something that you can buy to replace if you want to. It's placed there as a direction for the technician to go, knowing that what that is saying is it's somewhere in your vent system or your pressure system. So that's why he would know to look at the pressure switch, making sure all the connections are good. The hose is not clogged, which you can remove these. You can remove the whole thing here. And you can just kind of blow through that tube, double check. There's nothing in there. Obviously remove this before you blow into the tube, because how are you going to be able to get it out of the other side? Just saying. So make sure that's good. It's snug. You've blown it out. It's still doing the same thing. That way we know, okay, it is either the pressure switch or something else going on. So your inducer motors can look different. I have a common style here. Some of you might be saying, oh yeah, mine looks like that, or something similar. This cooling wheel could be plastic on yours. See, this one here has a Goodman part number on it, and this is a pretty common seller. But as you can see on this style inducer, the nipple here that can become clogged is actually on this part of the inducer motor instead of plugged into the other compartment for the carrier style design. So just to let you know, if you see this mounted up in there, in which this one's definitely seen some bad water damage coming here. If you see something like this in there, this is in fact your inducer motor, and we'll go over how to test these later. But that could also be a culprit if you're getting the pressure switch stuck open code. This just gives you an idea of how the same parts can look so different. Anyway, moving on. So now that we know everything is connected correctly, we're going to turn on our unit, and technicians, my dual port manometer with pressure switch tester is on the fritz. So we will do a separate episode with you on how to use or how to test a pressure switch with your dual port manometer and pressure switch tester. For now, we're going to do some simple things that homeowners can do to figure out if it is actually the pressure switch. So let's take a look. Now that we are sure our door switch is suppressed properly before we turn on our heating to test, we're going to have our multimeter, and yours does not have to have microfarad like mine. Just make sure you have it set to your ohms and your continuity here. Because what we're going to be looking for is we're going to make sure that we do have a line through so that the board knows that everything is hunky-dory and we can keep the heat on. So we're going to be placing our leads and double checking that we are on the correct setting before we do so. Okay, very first thing that should be happening here is that inducer motor should be coming on, which it is. So we now know the inducer motor's coming on. Now to do extended testing, just to make sure it's not the inducer motor, you're going to need, there we go. Now ours is going to fail out a couple of times because obviously it's going to try to ignite and it's not going to. So when this comes on, what it's doing is it's pulling a vacuum. It's a negative pressure that is going to essentially pull the contacts close. Once that happens, you should be able to read continuity because it is in fact making contact for that line through. Now ours is going to try to light, the igniter is going to come on, and normally that is a dead giveaway that the pressure switch is fine if your igniter is actually coming on. So now what we're going to do is put one lead here and then one lead here. And you can hear that beep, so you know there is continuity. When we're looking at our meter, if it is in fact below 0.8, then there is little to no resistance, and we know that those contact points are making a good connection, therefore continuity. Now you could do a voltage, I believe it's called a voltage drop test, but all that's doing is that's checking to see if your voltage is being impeded, because the contact points are corroded and they're not making a good connection. So there's our 3 tries that the system is essentially trying to do. Once it fails on that 3rd try, it's going to go into a lockout phase or a purge. Any carbon monoxide or toxins that are in the air. And once it does that, it will go into a lockout mode. If you're getting a lockout code, what that means is you need to reset the power. So ours is a light switch. Yours might have something different. Now, when this is off, you should not read continuity. It should be open, just like this. So if you put your leads on here and you are still getting a beep, you're getting continuity, your pressure switch is stuck closed, therefore it is bad. Now you'll see a lot of videos that talk about jumping around the pressure switch. And here's the deal. You could jump around your pressure switch, and all you'd be doing is you're taking these wires and you are jumping them together, and we'll show you what that looks like in just a moment. All that's doing is it is providing a line through, telling the board that it is making connection or contact and everything is fine, and should proceed to lighting the igniter, or rather turning the igniter on, and then sending the signal to the gas valve to open. The issue with doing that is it may or may not tell you if the pressure switch is bad. And we'll talk about that in just a moment, but for now, let me show you how you're going to jump around these wires so we can test and see if possibly it could be the pressure switch that is bad. So what we are doing here is we're essentially making a line through. So since our 2 connectors are here, what we want to do is remove those wires. And since it's a line through, the main thing we want to be concerned about is making sure that this isn't going to short somewhere. So it's really nice to have an insulated jumper like this when you're testing. But in certain situations, obviously, that's not going to fit. So what you could do is, if you have some gator clips, again, this is not high voltage, so it's okay to put these thin gauge wires on here because it is a line through. So what we're going to do is connect to one line, and then when we are jumping around the pressure switch, here's the important thing to remember. This line is not closed on startup, meaning those contacts are not making a connection when the unit first starts. And see, this is where our safety comes into play. If the pressures are not correct, then the pressure switch is going to stay open so that those contact points don't in fact make connection and cause issues. This is extremely important because no one wants to die from carbon monoxide poisoning. So that being said, this all has to be unrestricted. This needs to be able to be closed based off of the pressures listed on the pressure switch. Now, unfortunately, there are some that do not list them, and you have to go online and find out, based off of the part number, what those pressures could be. And some of them are extremely frustrating to find. So that is what our water column pressure is. And you will see pressure fall and pressure rise, or PF and PR. And I'll explain a little more at the counter as to what that means as far as pressure switch goes. Just know that this is under negative pressure, and that is what is going to pull that closed, meaning your inducer motor has to be working properly in order to pull that, vacuum it, and make connection. So when that happens, the point we're trying to get to here is that this cannot be connected on startup for that reason. You need to wait until this comes on, let it come on maybe a few seconds, and then we're going to jump here. And once we jump here, then it pulls the pressure switch closed, otherwise known as it is making a line through. And that is what we call bypassing the pressure switch. Again, this might not tell you if it is bad because often the pressure switch is not bad. But for simplicity's sake, this is something we're going to test to make sure by process of elimination, it could in fact be the pressure switch, or at least that we're heading in the correct direction. We've jumped around the pressure switch and everything comes on, it works, it's good to go. That's where we would actually check the continuity. We would connect everything back up the same way. And then we're going to put our meter to continuity. So once that is pulled closed, we make sure that it is making a good connection and it does have low resistance. So once we know that we have checked both of those, we at least know we can rule out the fact that it is making a connection. And even though we've jumped around it and it's working, it could possibly be something else. So an easy way for that is to first check for continuity. If it is making good connection and it is reading low resistance, to me, even if you were to jump around it and it works, there could be something else at play. Now, if you do go ahead and think it's old, I'm going to replace it, let's just go ahead and do it anyway. So if you do replace that and then you have the same issue, you know that it's either a restriction somewhere in the line. So as I've said, you want to take your hose off, blow into that. There is a connector here that is going to slide onto, it's called a nipple. Just make sure that is also free and clear. If everything is free, there's no clog that you can think of, the connections are good, and you know the switch, it's a possibility, but you know and you're pretty sure that that's not bad when you get it, then you're going to start looking to your inducer motor or potentially clog in your vent pipe. Maybe an elbow or something has become disjointed. It can happen over the years. Or if you've recently had roof work, your cap could have gotten crushed in, an animal might have made its home. A couple of the things that it could be if it's not your pressure switch. So for simplicity's sake, what we're doing here is we're showing you what you could look for before deciding to purchase a pressure switch. They don't go bad as often as you would think, even with age. I've tested many that were old that actually were functioning just fine. Now, replacing older parts, I can definitely understand wanting to do that. But what we're doing here is we're diagnosing to make sure that we're not purchasing parts that we don't need. Once we're fairly certain that this is making a good connection, and we're going to connect everything back up, we've done our tests, we suspect it might be something else, we're going to let it run its cycle. During this point, this inducer motor should never shut off. If this is making a lot of noise and you can't physically turn it like this, your bearings are probably locked up and it's time for a new inducer motor. We'll get into checking inducer motors later, but for today, this is a good start to see if it could be this or something else. So if we arm ourselves with the knowledge of, I need to make sure this is clear, I need to make sure there's no clog, and I need to make sure these connections are tight, everything going in line like this limit switch here, and not all units are going to have this. This is something they've put in line extra here to cut the power to the pressure switch. And then we've also checked for low resistance and continuity, basically. Then we know that this is potentially doing its job, and it could be something to do with your pressure or your vent system. As always, thank you guys so much for joining me today. I hope that I've helped all of you today in understanding how this works and what else the problem could be if you have replaced your pressure switch. If you feel like I haven't covered something or you have a question, just leave it in the comments below and I will get to it as soon as possible. Thank you so much for joining us today, and I hope you have a wonderful day and a great rest of your week. Take care, guys.